Now the topic is soil pH. Soil pH is a key factor in farmland. It controls the availability of plant nutrient, microbial activities, and crop production. Soil pH or soil reaction is an identification of acidity or the alkalinity of the soil. It's normally its acidity and alkalinity are measured in pH unit. It's a pH scale. It ranges from 0 to 14. So pH is normally identified by the power of hydrogen or the potential hydrogen ion or the active hydrogen ion. We are all familiar with the hydrogen and nature of the hydrogen. Now come to the word that is ion. An ion is in charged particles. Hydrogen ion plays a vital role to determine soil pH level. The hydrogen ion concentration expresses as a pH. The range of pH scale varies from 0 to 14, and the value of any substances, the pH value below 7 is acidic, and the substances, the pH value above 7 is alkaline or basic, and the 7 is the neutral. The 7 is the neutral. Why the 7 is neutral? I will discuss it in another video. Please go through this. pH value is actually measured of the hydrogen ion concentration. Okay, and it's normally identified by the negative logarithm. And for the pH scale, the pH 1 unit of pH decrease 1, the acidity will increase by the factor of 10. This is the basic principle of the pH scale. What is the basic chemistry behind the pH? Okay, those are the oxygen molecules. Those are the oxygen, H2, 2H and O. These oxygen atom contain two molecules of hydrogen, one molecule of oxygen. These oxygen, this one molecules of oxygen, this is another molecules of oxygen, and there is an interaction among the molecules of oxygen. What will be the result? Here, from an oxygen molecules, one hydrogen atom is released, and that released hydrogen ion added in here, and here that molecules contain 3 hydrogen. There was 2 hydrogen, one is released from that atom, that molecules, water molecules, and added here, and it become AH3, that is the hydronium, and that is the negative ion, OH minus ion, that will be the hydroxyl ion. This is the basic chemistry behind the acidity and alkalinity. Okay, soil normally, the acidity of the range of the soil normally varies from 3.5 to 10. In higher rainfall areas or the humid climatic condition, pH value of the soil typically ranges from 5 to 7. And in the desert climatic condition or semi-arid climatic condition, soil value of the soil pH varies from 6.5 to 9. Soil is naturally either acidic or the alkaline, and it is measured with the help of pH value. There are several instruments to identify to measure the pH value. Normally, litmus paper helps to identify whether the substance is acidic or alkaline. Out of that, there is digital pH meter, and the help of soil kit, student can identify the soil pH. In soil kit, student with the help of color cards can easily identify the pH value of a soil. So, climatic condition plays a dominant role to determine the soil acidity or the alkalinity. Humid climatic condition is responsible for the acidic soil, rather slightly acidic soil. I am not talking about the extreme acidity. An arid to semi-arid climate, rather dry climatic condition is responsible for the alkaline soil. Uh, Neutral soil normally ranges from 6.5 to 7.5. The substances, the soil pH value ranges higher than the 7 is alkaline and below the 7 is acidic. Okay, this is the formula. That formula helps to identify the soil acidity or alkalinity. pH is equal to negative log plus H plus ion by hydrogen ion concentration. Here, why we are taking hydrogen ion concentration for measuring the soil acidity or alkalinity. Among the molecules, the hydrogen is the simple possible molecules. That's why Danish scientists selected hydrogen ions to identify the pH level. Okay. And another thing is that the density of a hydrogen ion in neutralized or standard condition, the density of hydrogen ion by hydrogen mole ranges from 1 mole to 0.00000001 mole, that per liter. This is the wide range of density. The concentration of hydrogen ion in any solution or in any substances likely to encounter will ranges from 1 mole to 0.000001 mole per liter solution. It's normally identified mole per liters. That's why hydrogen mole is taken as a consideration for identify the pH level of a soil or any substances. This is the pH scale, and the acidity increase from 7 to towards 0, and alkalinity increase 7 towards 17 towards 14. Okay. Here I would like to mention one thing, that the in neutral condition, 7 is the neutral condition. And why 7 is the neutral condition? In neutral condition, the hydrogen ion and hydroxyl ion water molecules contain two ions exactly same, exactly equals, that is H plus ion and OH minus ion, and that is the hydroxyl ion concentration are equal. Therefore, pH level of fresh water is 7. This is the standardized. And from this 7, uh, from 6, 5, 4, 3, 2, 1, its acidity and the concentration of hydrogen ion gradually increasing, but the value of pH is gradually decreasing. There is a reverse or inverse relationship. Okay. And anything by any substances above the pH level of 6 or 7, the soil will be the basic. Come to the next slide. There is a relationship between hydroxyl ion and H plus ion, hydrogen ion. Here there is a positive relationship with the alkalinity and the scale of pH, and negative relationship scale of pH and the acidity. Okay, logarithm scale is normally used to identify the soil pH because logarithm scale define the wide range of values, and that is ultimately helps to identify the soil acidity. And soil pH scale is exponential scale because it's just like a Richter scale or the decibel scale. It's like previous slide. Here you can see that there is a lots of range. Range is quite high. That's why in here the logarithm scale is taken. Okay, and there is a greater the acidity, lesser the pH value. There is an inverse relationship. Okay, now come to the point. What are the natural source of soil acidity? Rainfall and leaching, rather climatic condition leaching. This is the very common thing which are responsible for the soil acidity. And the nature of parent material, just like a basalt. Basalt is slightly acidic in nature. The soil derived from or origin from the basalt normally become acidic. Therefore, the rainfall, leaching process, and the nature of parent materials are the prime natural causes for the soil acidity. But organic matter decay, harvest of high-yielding crop, nitrogenification or ammonification are the another anthropogenic causes responsible for the soil acidity. And moreover, acidic rainfall. Normally, the rainwater is slightly acidic. Normal condition, rainwater is slightly acidic. It's range from 5.6 or 5.7. But due to air pollution, the rainfall become more acidic and become strongly acid. It's become 3.5 to 4. That is the very strong acids, and that is also responsible for the soil acidity. And soil acidity hampers the plant growth. Soil acidity is a potential serious land degradation issue. When the soil becomes too acidic, it is responsible for the degradation or decrease of the availability of soil nutrient and increase the impact of toxic element, and that is very harmful for the plant growth and cultivation too. Decrease the plant productivity and water consumption pattern of the roots of the plant, and it also leads a negative impact on the nitrogen fixation process. So soil acidity is a vital thing in the cultivators, to the farmers, to the nation's productive system or nation economy. Now the question is how we will manage the soil acidity. Actually, usually crushed limestone, mixing of crushed limestone is the easiest and simplest way to manage to rise the soil acidity, to manage the soil pH level. The amount of lime required to ameliorate the acidic soil will vary, but it's depend on the condition. But the soil which is very severely acidic or soils prone to become more acidic, then the frequent liming by every year using limestone is very essential step. This is the very simplest way to manage soil acidity. Okay, and another thing is that the to plow to manage the plant species or the crops which are normally grows in the acidic soil. Now come to the point of alkaline soil. The alkaline soil management is very difficult because it's not the prudent step to adding acid agent on the soil, because it's not the feasible, because alkaline soil creates the buffer layer. There is a capacity of buffering, and that will provide the harmful result. It is not the prudent step to apply sulfuric acid or sulfur and pyrite in the soil. It will lead adverse impact. It will change the soil pH scale that ranges from 0 to 14. So another method is that gypsum will reduce the soil solidity, and it can used up to some extent to manage the soil alkalinity. But normal and natural, rather environment friendly way to manage alkaline soil is that using alkalinity tolerant plant species and vegetation or crops or pasture that can reduce the impact of high pH level. This is the natural way to manage soil alkalinity. It is not encouraged that you use sulfuric acid or the pyrite. Those are not the prudent step to manage soil alkalinity. A few example of acidic soil. Laterite soil, cyanogen soil, podzol soil, or are the example of acidic soil. Here, acidic soil is very good for the tea plantation, for so the paddy cultivation, potatoes, cotton, watermelon, all these things. So we can easily go for the cultivation, all those cucumber, tomato, cabbages, pumpkin, tea, cotton, all these things we can manage the acidic soil. And a few example of basic soil: clay soil, black soil, black alkali soil. Cholumchak is a very good example of basic soil. So which crops and which vegetables are alkaline friendly? Asparagus, beets, sprout, cauliflower, garlic, banana, sweet potato, all are very good in alkaline soil, provides good productivity. Rather using others means use as cultivate those alkaline friendly fruits and grains will provide the better result. Those are the basic thing of soil, alkalinity and the salinity. But this slide is not incomplete. So go for the another video I have uploaded that will provide the clear idea about the soil pH scale. It is bi-directional scale. Thank you very much.